Alright, next lesson. Can you taco tongue and evil eyebrow? When I saw this, I'm like, I don't know. I don't even know what taco tongue is. You guys should teach me what it is next time I see it. Okay? Alright, so some people believe that the ability to taco tongue and evil eyebrow is something that you are born with. Is that true? Are two abilities somehow related? Well, I don't know. So, I'm supposed to survey you, but you're not here. I miss you guys. Okay, so let's say this is what I got. I survey everyone, and so I ask, can you do evil eyebrow? Can you do taco tongue? Raise your hand, and that's what I got. Okay? Alright, let's go ahead and find the total for each. So how many people can do the taco tongue? Yes, there are 5, 8, 7. Add it all up. 20 of you. How many of you cannot do the taco tongue? 7, 2, 1. 10 of you can't do it. How many of you can't do the evil eyebrow? These two, so 12. How many of you sort of do evil eyebrow? 10. How many of you can do eyebrow? 8. Okay, now what will be the total of the class? You can either add these two. What's 20 plus 10? 30. Is 12 plus 10 plus 8 32? Oh yeah, it better be the same. So whether you add that way or this way, same thing. By the way, folks, this is called a two-way table. Why is this two-way? Because it's two-way, right? Yeah, it tells you two separate information. It tells you about evil eyebrow ones, and it tells you information about the taco tongue. And then you better get familiar with that. Okay, so suppose that we randomly choose a student from a class. Find the following probability. All right, what does this mean again? That's a probability of no evil eyebrow. Okay, so how many of you says they can't do evil eyebrow? There are 12 of them that says they can't do it. And how many total students do we have? 30. So how do you find the probability of such thing? No evil eyebrow over the total students, 30. You good? Alright, what about sort of evil eyebrow? Sort of evil eyebrow. There were 10 of you said that out of 30. 30. Alright, so what's the probability of no evil eyebrow or sort of evil eyebrow? Folks, remember the previous video you just watched? If it's or, what do you do? Probability of no evil eyebrow plus probability of sort of, which is what? No evil eyebrow was 12 over 30, sort of was 10 over 30, we get 22 over 30. Yay. Okay, so far. Now, suppose that you randomly choose a student, find the following. Yes, taco tongue. Alright, yes, taco tongue. There were 20 of you said that. You can. So 20 over total number of students, 30. Yes, evil eyebrow. Yes, evil eyebrow. Yes, evil eyebrow. 8. 8 over 30. Probability of yes, taco tongue, or yes, evil eyebrows. How do you do it? Probability of yes, taco tongue. Technically, what are you supposed to do? You're supposed to do just add these two. Isn't that what we did on the previous problem? Yeah, so you're supposed to get 28 over 30. However, look at the table. All right, who said yes to taco tongue? Yes to taco tongue. These 3, or yes to evil eyebrow. These 7 and 1. Do you guys see that? Okay, once again, who says yes to taco tongue? These 3. Who says yes to evil eyebrow? These 2. Does that bother you? Oh, it does. It should bother you. What's bothering you? That 7 right here, it overlaps. Do you see that? Those 7 people can not only do the taco tongue, but they also can do the evil eyebrow. So if I were to add these 3 and add these 2, that 7 counts twice, which is not good. We only want to count these 3. So how many are they? 13 plus 7 is 20. 21. We want our answer to be 21 over 30. But how are we going to get there? Here's what we're going to do. You're going to do probability of yes, taco tongue. And you're going to add probability of yes, evil eyebrow. But since there is overlapping, 7 of them, you're going to subtract probability of yes, taco, and yes, evil. I'll show you. Okay, so how many says yes, taco? Yes, taco. 20 over 30. How many say yes, evil? 8 over 30 minus probably the yes, taco and yes, evil. Yes, yes. 7 over 30. What do you get? 28 minus 7? 21 over 30, which is good. That's what we're supposed to get. Okay, so what's the difference between these two? We're going to go over it next page, but should I go over it? No, we're going to go over it next page. Just know that the difference between 2 and 3 are the 2. There's no overlap. 3, there's overlap. Okay? Alright. Now, suppose that we randomly choose a student from a class. Find the following. Probably of yes, evil eyebrow. Yes, evil eyebrow. 8 over 30. Yes, evil eyebrow. You can see. Given the person is a yes, taco tongue. It gets a little tricky. Fold it so you can see better. Alright, how many people said yes to taco tongue? Yes to taco tongue. So out of 20 people, given that someone says yes to taco tongue, yes to you, evil eyebrow. 5. No. 7. 7 over 20. So do you see the difference? On the previous one, everything was denominator of 30 because it's to the whole student population. But difference on this one is that I don't want out of everyone. I want it out of only person that is yes to taco tongue, who has evil eyebrow. Okay, let's do one more. All right, out of people who says no taco tongue, so out of people who have no taco tongue, 10 of them, who has yes, evil eyebrow? 1. Okay, and what is this called? This is called a conditional probability. So instead of your denominator being everyone, it's going to be conditioned to certain population. Okay? Alright, what do result from number 4 tell you about ability to taco tongue and ability to evil eyebrow? What do you think? So if you can taco tongue, you can do the evil eyebrow 7 over 20. You can't. You can do 1 out of 10, so it's pretty small. So I'll say, if a person can do a taco tongue, they are more likely to be able to do evil eyebrow than if they couldn't do the taco tongue. Right? That's a higher chance than 1 over 10. If a person can do taco tongue, I'm more interested in what taco tongue is now. They are more likely to be able to evil eyebrow than who can't evil eyebrow. Interesting, interesting. Cool. Alright, next page. Now let's write down all the summary. Alright, 3 things. Number 1, we're going to learn what's called mutually exclusive. Very important vocabulary for probability. What is mutual? When you hear the mutually exclusive, what does that remind you in real life? You know that means there's nothing in common, right? Yeah, exactly. These are the events are mutually exclusive. I'm just going to use MC. Well, I can't spell ME for the writing purpose here. If they cannot happen together. They can't happen together, right? So, example. What example can it be? You can't be a junior and senior at the same time. So they gotta be mutually exclusive, right? Or you can say my final math grade, getting A versus getting B. They are mutually exclusive. You cannot get A and B as a final grades at the same time. So those are all the examples of mutually exclusive. Okay? All right. Number 2, or problems. Okay, so probability of A or B. On the previous lesson, it was what? Probability of A plus probability of B. However, You know how we said it's going to be harder? Yeah. How is it going to be? It's going to be probability of A plus probability of B, which is the same as the previous one, but you're going to subtract probability A and B. So what does that mean? If it happens to have a same overlapped area, you're going to subtract after you add each event. When do we do that? We did that for number 3 on the previous page. Remember that? Probability of yes tongue or yes evil eyebrow. We added the yes tongue. We added yes evil, 8/30. But then we subtracted those people who can both do the tongue and the evil eyebrow. Subtract 7/30. Right. Cool. Now, but then over here, number 2, did we subtract anything? No, we didn't subtract anything. We just added it. Then why did we not subtract? Well, let's look at it. Remember, 2 things were no evil eyebrow and sort of evil eyebrow. Well, there can be no overlap. So remember what I said, what happened when 2 events cannot happen at the same time? They're called mutually exclusive. So actually, these 2 are mutually exclusive. That's why you're not subtracting anything. So let's write it down. If A and B are mutually exclusive, then probability of A and B is 0. Right? What's the probability of someone being junior and senior at the same time? 0. Because you can't happen at the same time. Cool? Alright. Number 3, conditional probability is, you write it like this. Bar in the middle. So probability A given B. You can read that as given. Oh, well, let's write it down. Probability of A given B. So instead of my denominator being every possible outcomes, your denominator is going to be just probability of B happening. So actually this will be probability of B, probability of A given B, which I don't think your note has that written down. I'm not sure why we're not doing it. But oh well. Alright, let's check. Students at a small high school in Michigan were asked, which subject area do you prefer, math or English? And their grades level are recorded as well. So this is two-way table. Why? 2 separate information. Their grades and their favorite subjects. Students were only selected. What is the probability they're senior who prefers math? Seniors right here. Who likes math? Senior who like math? 40. 40 over how many total students? 250. Okay, so let's write it down. Probability of senior and math. If a student who prefers math is chosen, so we're not talking about everyone, we're talking about students who like math. What is the probability that they're the freshman? So we're going to write it like that. So what does that mean? What is the probability that someone is a freshman given they like math? One more time. This is the probability that someone is a freshman given they like math. Okay. So given they like math. How many people like math? 119 students like math. That's out of those. How many are freshmen? 20. Cool. Alright, now next one. If a freshman is chosen, so given someone is a freshman, what is the probability they like math? Okay, so given someone is a freshman, look at the freshman on the right side, they like math. Math. So these 2 are opposite, right? Well, not opposite, they're different, right? Different conditional probability. The top one is given someone likes math, bottom one is given someone is a freshman. Alright, so given someone is a freshman, how many freshmen do we have? 64. Who likes math? 20 of them likes math. Okay? Alright, suppose a student from high school is randomly selected. Find the following. You know what? I'm going to do that with you when I get to the class. Thank you for watching. Now go ahead and you can re-look at the notes or start your 6.1 IP. Thank you.